The machining of parts is achieved using machine tools that bring cutting tools into contact with the workpiece. These cutting tools remove the unwanted material, shaping the part. Traditionally, the cutting tool's motion relative to the workpiece was controlled manually by a skilled machinist. But with the onset of mass production and the increased demand for part quality and uniformity, numerical control, or NC systems, were developed. These NC systems control machine components by converting programmed instructions into output signals. These output signals in turn control the machining process to produce a workpiece. Computer numerical control, or CNC, built upon the standard numerical control production capabilities by incorporating an integral computer processor to govern the machine controls. Programmed instructions, or data, in the form of a part program is translated by the machine control into output signals that control machine functions, such as spindle rotation, cutting tool movement, workpiece movement, tool changing, and cutting fluid control. Computer numerical controls hold several advantages over standard numerical controls, including part programs can be manually edited on the onboard computer. Part programs can be run from computer memory. Workpieces requiring complex multi-axis machining can be produced. And machine and control diagnostics may be run, stored, and displayed during machining. These CNC advantages offer increased parts production flexibility, greater machining accuracy, and more programming versatility. The use of computer numerical control is widespread in manufacturing and is used in turning, milling, hole making, welding, electrical discharge machining, abrasive water jet cutting, punching, laser cutting, and many other operations. All computer numerically controlled machining begins with a part program. A part program consists of sequential instructions or coded commands that direct the machining of the part. Part programs are primarily generated by either manual programming of commands or, more commonly, by the use of computer-aided part programming systems. To understand how computer numerical programming works, first requires a basic understanding of key computer numerical control principles. The common factor that all computer numerically controlled machine types share is their ability to accurately and repeatedly control motion in various directions. Each of these directions of motion is known as an axis. Depending upon the machine type, the number of axes available for control commonly range from 2 to 5. Additionally, a CNC axis can be either a linear axis, with motion occurring along a straight line, or a rotary axis, with motion occurring along a circular path. Each axis consists of a mechanical component, such as a machine slide that moves, a servo drive motor to supply power for the movement, and a ball screw that transfers the power from the servo drive motor to the mechanical component. These components, along with the computer numerical control functions that direct them, is called an axis drive system.